Hi and welcome to the next tutorial. In this one we are having a look at the third part. So here you can see it on the screen, and the focus for this tutorial will be to go into constraints, and also we're going to get some work holding. So rather than just machining the part in thin air like we did on the last one, this time we're going to add some work holding, some vices, and we're using the Lang system. They have some really good stuff that you can download on their website, so that's what we're going to be focusing on. So the first thing we want to do from this part, obviously open it up if you've not already, and we want to kick off our manufacturing session. So I'm going to go ahead and do that. New. Manufacture. We'll do that. It's a general setup. And the name for this one will be It's going to save. I'm just going to create a folder in here. Save it inside there. Okay, so now we have our manufacturing set up. So what I want to show you here is I'm going to include this folder called work holding, and there's 3 different parts in here, which is going to be our Lang plate, the vice base, and the vice jaws. So the first thing I'm going to do here is we are going to build up from the MCS. So you can see our world coordinate system and our machining datum here, our ZM, YM, and XM in the middle. So I'm just going to move the part. Normally when I start a session like this, the first thing I do normally is just to move the component just out of the way. Let's just take it up somewhere like there. Doesn't really matter where. I'm going to drag it up, and the way I did that was in your geometry tab. Assemblies tab, you can do it either way. You got the move component feature. So this is a component because it's a part. So, and then we're going to go into this in a minute, but yeah, just for now, just keep it on dynamic and just use a specify orientation, and you'll get the little drag handles. But yeah, and then you can just drag it about in whichever way you want, like this. Yeah. So now this is dragged out of the way a little bit. Now I'm going to bring in a new part. So we're on the assemblies tab, and I'm going to add a component. So it's asking you what part to place. So we want to open and look for your folder called work holding that you should have if you've downloaded it from my Dropbox. And the first thing we're going to add is a Lang plate. This is the bottom. This is the first thing that you need to add. So here it is. So if you're not familiar with the Lang system, I'll just quickly sort of show you how it works. You've got all of these little holes here, and you can have any sort of mating part, as ours, for example, will be the vice. And the vice underneath has these 4 little dowels in, and they just drop nicely into these holes here. And then in here, there'll be a screw, and you can just tighten it up. It's a really, really nice system. So I've just brought the Lang plate in, but we don't know if it's in the middle, for example. So if I just move this off center, just to demonstrate. So the best thing that I do, or what I'd like to do here, is I use the point information. So point information, and if you can't find it, just type it in the top box like I do. And I'm going to hover this point here. So you can see when I'm hovering here, if I hover at this point, you can see how it's got it highlighted, this point where my cursor is. Whereas if you sort of select the middle of the line, now you can see it's picking up this center point of the circle. So I want to pick that center point. And you can see in X, I'm out of position by 50 mil. In Y, I'm out of position by 90 mil. This is to the center. So this plate wants to be in the middle to begin with. So how is the best way of doing that? So I'm going to move component. And like we just saw there, we need to move 50 mil and 90 mil. So a couple of motions that you have in here. For this, we'll use distance. So I can hit distance, and then what axis do we want to move in? We can either set that here by saying X plus or X minus, or you can just hit these little arrows. Either way is fine. So in X, I need to move over 50 mil. And in Y, I need to move over 90 mil. Okay. So now I'm hoping that this center point is absolutely in the middle. So let's just check that again. So point information. 0, 0, 0. So we are spot on in the middle. The next thing that I would like to do, or at least show you a little bit. So here you've got constraints. So all of these little boxes here, these are all different kinds of constraints. So currently, although we've positioned this part, if we start constraining other things to it, it still has the ability to move. So that's the first thing we want to restrict. This plate never moves now. So here you've got a fixed constraint. So I'm going to fix this in position. Okay. So now, regardless of what happens, this part cannot move anywhere. Okay. So the next thing we need to add. So add component again. Open up, and we want the lang base. This is the base of device, like you can see here. So here's something interesting. So when you're adding components, you never want to add it as target. Always workpiece, especially for like vices and stuff like that. Target is something which isn't really relevant yet for you guys, because a target is basically, for example, if you had a template file. In that template file, you probably want to have a block somewhere in the middle, and that block would be a target part, meaning when you start a new manufacturing session from that template, it will replace your part, so this part here, with the target part. That's just so your part doesn't, appear in the middle of nowhere. Okay, so I'm going to change this component type to workpiece, and the rest of it's all fine. So now you can see it's somewhat in the middle. I don't know if it is in the middle exactly. I'm not going to check it because we're going to constrain this. So let me just show you. You can see here you've got 4 holes on the underneath of this vise, and them holes want to line up with these holes here. So if we just have a look, you've got a few constraints in here. So let me show you one constraint. This is what most people would do off the bat. You've got a concentric constraint. So you can make 2 circles concentric to each other. So you can say this circle here to this circle here. And now you can see it's moved down. But the issue with this is now this is only one pivot point. So for example, we have constraint these 2 here, but what we'll see is there's nothing to stop the part rotating. So I'm going to try and move this part. If we just do drag. So we shouldn't be able to move it in X. No, we can't move it in X. You see the part's not moving. We shouldn't be able to move it in Y. But we can still move it around that point. So this is why I don't like this feature. And I know what you're saying. Like, yes, we could select the bottom hole. So let me undo it. So in theory, we could do this hole to this hole, and then this hole to this hole, which is totally fine. The issue being is that once you select it here, so if I select that and this, I now can't see these 2 holes. Can't see them. So I'll show you a different way, one that I prefer. And I've just lost my part. So add that back. Okay, so this is the way I would do it. So in here, I have a couple of features, auto align being one of them. So auto align, you have a few different options, or you should. Center axis, yeah. So auto align, it's sort of like, it's kind of like in third, but for constraints. So it's going to try and pick what it thinks you're trying to do. So for here, what I'm going to do is I'm going to select, you see how if I hover this hole, I'm getting this center line here. The center line of this hole. So if I just hover the hole first, and if I do it on here, you see how you get this center line appear. So I want to do this center line. I'm going to do the same here in this center line. But I now know that is perfectly constrained. And I'm going to do the same here. This center line. to this center line. Okay, so now I know that this part can't move in X, it can't move in Y, it can't move in rotation, but it still can move up and down. So then the next thing we want to constrain is face to face. So I'm still using auto align and I'm selecting this face and I want to align it to this face. So that should snap nicely. And what you should find now, if I try and move this, it should all be perfectly constrained. So if I just move it dynamic, I can't move it in X, can't move in Y, can't move in Z, can't rotate, and can't rotate. So that is perfectly constrained. Okay, next up is the vice jaws. So again, let's add the component. I'm looking for this vice jaw now. So you can see, like, I'm not sure where that's come in. Oh, here it is. It's somewhere underneath the part. So first of all, I'm just going to drag this up a bit. And then also I can see this orientation's wrong. So I'm just going to flip this 90 degrees, like so. Okay, now I press OK. So we've got a vice jaw in here. It's somewhat, you know, aligned in X and Y, but now we're going to constrain it. So I'll show you a really nice tip for this one. So here you have center. You've got a center constraint. So we're going to center this and we're going to do 2 to 2, which means you can either do 2 faces to 1 face. So you could say, I want to align the center of this face and this face, which would then project a line in the middle. And then you just choose, I want to align that to, for example, this line. I find the best one, and the one that I use 99% of the time, is 2 to 2. For that, I'm going to go, I want to align this and this to this, this. That's going to put me perfectly in the center. And then the next thing will be, I want to align, just apply that. I want to align the middle of this and this face, because this is the rail, to the center of this and this. Like so. So now what we should see with this jaw is we should be able to move it along the Z-axis, or Y-axis, sorry. So we can move it along this axis, which is fine because that's what you expect from a vice jaw. But we shouldn't now be able to move it in X, which we can't, and we shouldn't be able to move it in Y or Z. So yeah, this jaw is constrained nicely. Okay, so then what I like to do here is just drag it somewhat out this way, like so, somewhere like that, that's fine. And now we need the second jaw. I'm not going to add another part and start constraining it again. What I will do is I'm going to move this part. So I'm going to move this jaw. And in the motion, I'm going to use an angle. I basically want to try and mirror it to the other side. So I'm using an angle, and the vector that I'm moving this through is this Z plane, so I can spin it 180 degrees. My axis point, so this is really important. Because we're working from the center, now I can just say 0, 0, 0. So you say specify axis point. So I could go and I could select this face here or anything like that. But if you just hit this 3 dot box, you get this little information window, I guess, where you could start manually typing in where you want the point to be in X, Y, and Z. But for us, we know it's just bang on 0, 0, 0. It doesn't need to be up here or anything because we just rotate around this middle point. So we can just say yes to that. And then the angle. So this is important. So you want to copy it. So the mode we want to be on is copy. And you want to do this before you change the angle now. Now I can put the angle in at 180 and bang. There we go. And now we've got our second jaw. The issue is now is this won't be constrained. So although we've mirrored it, this has got no constraints to it whatsoever. So let's just go ahead and add the same constraints as we did before, 2 to 2. So we constrain in that way. And now we need to constrain in Z. So I can't see this jaw here, so I'm just going to hold somewhere around here, and I'm going to wait for the 3 dots to appear, and then click. And now I get this window, and I'm looking for this vice jaw face here. I'm going to do the same underneath. I can just see it here. And I want it to be in the center of this one and this one. Okay. So now this jaw is also constrained. So it can't move in X. It can move in Y, which is normal for the jaws, and it can't move in Z or rotate. So we're good there. The next thing is, if I move this jaw, I want this jaw to come with it as well, to replicate what a normal vice would do. Currently, I can move this in Y, but this one doesn't move with it. So you'd have to then move that the same distance, which isn't ideal. But we can get around that really easily by just adding another constraint, another center constraint. So we want to constrain the center of these two faces to be in the middle of these two faces, so the outsides of the vice. So what you'll see now is, this is really nice. You'll like this. So now if I try to move this jaw, look at that. It all moves together nicely. So that's good. That is how we would set up a simple work holding fixture. And it looks really nice as well. So the next thing I want to just quickly go over before we go too deep into the setup of this is, what you'll see here is, you see all these constraints, they're all visible. So we want to just go into the constraint tab here, the constraint navigator. And if you don't see this constraint navigator, if you just come to the bottom, sort of in the fresh air of this bar, and right click, you'll see you've got this tabs button. This might not be ticked on as default for you. So you might just want to tick on the constraint navigator. Now you can see all the constraints that we've added. These aren't really relevant for now, but the one thing that is relevant is, if you're in the fresh air again of this window, if you right click, you can I think you might have to click at the top. There we go. Yeah. So if you just hover somewhere around the top and right click, you get the display constraints in graphic window. We want to turn that off just to make things nice and clean again. So this looks really nice now. This is a nice setup. So the next thing we need to do, we need to bring our vice, our part somewhat down near the vice where we actually want to hold it. So I'm going to move component. I'm going to bring this down. So this is how I would normally set up a part. So I'm dragging it down until I'm like bang on sort of limit. I know that I'm going to need a little bit of extra stock on Z here, obviously, because we need to mill past it. So I'm going to give myself, let's say, 6 mil. So 1, 2, 3, 4, 5, 6. You can see the distance went to 6 mil there. So I'm 6 mil clear of the vice jaws now. So what I'm looking at is this distance here. I can OK that. And now we need to make sure that this part itself is in the middle too. So again, we can use constraints. I'm going to do the center constraint. And this time I'm going to do the 1 to 2. And the 1 will be the center axis here. And the 2 will be the outsides. Okay, so I'm perfectly in the middle this way. I'm going to do the same again. I'm going to constrain the center line of this bore to the outsides vice to put me in the middle. So now if we check the center of this hole using the point information, we should see that the X and Y should be perfectly in the middle, which they are. So we know that this part is perfectly in the middle of the job. The next thing that we would need to do is to create our link body of this part. So remember, we never work from a design master, so we never work off this part. We always work from a link. So we want to come into geometry, wave link geometry, and we're going to take a link of this body. And you got obviously the few settings. The one we're bothered about is we need to make sure it's associative. Okay, so now we have that link. We can turn this off. We don't need this part anymore. And in our part navigator tree, we've got the link body here. I like to just give this a different color. So I'm just going to keep the link body selected. I'm going to come into display, edit object display. I'm going to change the color to something different, just so you know the difference between your link body and your design master. So now we can go and get our tree ready. So MCS mill, that's our main top level datum. So you can see, I can't see my WCS at the minute. If you just hit W, now it appears there. So I'm going to just move my MCS up because I want my datum to be the bottom of this jaw here. This is a very normal place to put it for Lang. Like Lang work holding, always bottom of the device. This is where the bottom of the billet's going to be. So let's just go and set that. So in geometry, here you have the more tab, WCS dynamics. I'm going to bring this up. I believe it's 113 mil. That looks about right, but we can double check it. So 130 mil, and if we just do the point information again, you can see how we've got the reference here of WCS. So we're measuring from the WCS. So we just check one of these points here, and you can see here this top level is your absolute. So 113 mil from absolute, which is here, and this figure here, this 0, is from your WCS. So our WCS is in the middle. I'm just going to save that. See, it's created like a little save plane, and that is just so I can select it when I come to do it here. So now I want to set my machine datum, so the top level MCS datum, and that is going to be not that one here, inferred. Now I can just go and select that like so, and then let's just go and set some default clearance planes. So let's just set the automatic plane to, I don't know, if this is 6 mil, then this is 8 mil, that's 6, 14, bit of stock on top, let's just say 20 mil. Avoid, these are all, yeah, you don't need to worry about any of those. Okay. So now we need to go and select our part in the geometry. So our part that we're going to be machining is this one. And our stock, we're going to do bounding. So we're going to do a bounding block, which gives us this. So here, let's just say 125 mil in X, 125 mil in Y, and the thickness is currently set to 10 because it takes it from our part. So we're going to want at least another 6 on the bottom. Let's just say 20 mil to be nice. That should give us plenty. And you can see how it's offset this down. So we want to we can change that around here in the Z position. So if we say 1 mil here, takes us to the bottom, and then we can, yeah, we got a mil on the top as well now. So that should be okay. Yeah, let's just give ourselves a touch more on the top just to be on the safe side. I know we're working in theory here, but it's always nice to be correct as much as possible. Because if this was a sawn edge, for example, if it was sawn, then it could be low and high in certain bits, and 1 mil might not be enough to clean it up. So we're just going to definitely make sure we've got enough there to clean that up. Okay. So we've got our stock all set up, and now you'll see that the jaws aren't, you know, in the right place basically. So I'm just going to go and move them. So assemblies, move component, and like we know, we can just move one jaw. And also what you'll notice here is this is about right, but we are getting close to the end. I mean, it'll probably be fine, but with these jaws, you can reverse them. So you can hold it like this, which gives you a little bit more room, but we should be fine this way. And again, we can use just constraints here if you wanted to. So we could do a touch constraint. So auto align, we'll just do this face to this face, like so. And that is us set up, ready for Op 10. So in the next video, we're going to go through some geometry creation. We need to split this part up a little bit. We also need to create a frame and start thinking about how we're going to manufacture this. But we'll get through that on the next one. I hope you enjoyed this one. And as always, leave me any comments if you want to see anything in future videos, and I'll see you in the next one.